A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth on December 17th. Comet, asteroid, or something else?
Something is wrong with 3I Atlas.
This object has just been discovered. 3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
And the James Webb Space Telescope has finally seen it. After passing the sun, the object should have dimmed.
To make sure that sunlight, which is dumping approximately 200,000 watts.
But instead, it lit up, over and over again. NASA delayed comment, but deep in the infrared spectrum, something shifted its course in real time.
It's moving at a velocity of about 135,000 miles per hour, so it's going really fast.
And Webb caught all of it. NASA kept it hidden, but now, the most advanced space telescope ever built has revealed something even stranger. The James Webb Telescope just uncovered what NASA isn't yet ready to explain: something alive. From the moment James Webb locked onto 3I Atlas, it was clear something didn't add up. This was not the icy, inactive rock astronomers were expecting. It has visible surface jets or reflection spikes caused by solar flare-ups. Nothing that pointed to the kind of volatile outgassing seen in comets like Borisov or Hale-Bopp. Using its NIR spec and MIRI instruments, Webb detected a source of internal thermal energy, a focused heat signature pulsing every 4 hours. It wasn't a flicker or random heat spike. It was a perfect rhythm, a full cycle every 4 hours. That pattern repeated without fail. No known interstellar object has ever done this. Not Oumuamua, not Borisov, not anything in our catalogs. Most comets spike and dip as they spin or erupt unevenly as gas vents open. But this was consistent. The pulse matched no known natural process, and it came from within. NASA didn't comment on this immediately.
From images, we also saw that this object is active, which means that around the nucleus there is some coma, which is an indication that this object is in fact a comet.
The James Webb Space Telescope had been quietly feeding data to teams at multiple institutions. Internal logs showed that the pulse pattern was flagged during the first 3 observation cycles, but the public release didn't happen for several more days. By then, the thermal signature had not only persisted, it had intensified. Some scientists called it a thermal anomaly. Others began calling it something else, a heartbeat. The location of the heat was just as strange. It came from the object's core. Webb's instruments showed that the heat wasn't rotating with the object. It was staying locked at the center. This implied either an internal mechanism not affected by outer momentum, or something capable of maintaining its own spatial orientation. If this object was generating internal energy, how? There was no sign of radioactive decay, no fluctuating trace elements, no obvious fusion byproducts. That ruled out natural thermal emission from decomposing material. And it didn't show characteristics of a tumbling fragment or reflective anomaly. This was a closed system with an internal energy source and predictable timing. At this point, NASA teams started comparing the signature to anything in existing databases, but the object defied every classification. Multiple observatories requested additional time on Webb. Several teams submitted priority flags, hoping to verify the anomaly or rule out instrument error. In private reports, scientists speculated that the internal activity resembled a self-regulating energy loop, something capable of adjusting to its own heat cycle, not driven by an external force. That idea was disturbing, because it meant this object wasn't just active, it was managing its activity. And nothing natural does that in deep space. NASA's public silence during this window raised eyebrows.
All there is to know about NASA's latest observations of comet 3I Atlas.
For almost 1 week, no official statement was made about the anomaly. Meanwhile, amateur skywatchers started comparing their own brightness curves and noticed the consistency. Eventually, a formal update came from NASA referring to the object's non-volatile thermal retention. The statement avoided using words like pulse or signal. It described the heat as internal variance and the object as under additional analysis. But by that point, the data was already public. Scientists at Caltech and Johns Hopkins had already circulated models showing the pulse lined up with specific directional alignments. And as more frames came in from Webb, something else became clear. The object's thermal bursts were not uniform in every direction. They were slightly stronger in a fixed axis, one that didn't shift with the object's spin. How could an interstellar object, moving freely through space, maintain directional stability inside itself. The only known way to do that is active control, either by mass stabilization, like a gyroscope, or by artificial dampening. In either case, we're talking about something that can isolate internal movement from external forces. And for that to exist inside an object this small, this compact, means we're no longer looking at a rock. We're looking at a system. By the end of the second week, Webb had collected over 50 hours of continuous data. Every part of the object's rhythm remained the same. Every pulse, every delay, every cooling curve matched the previous cycle. That kind of stability doesn't come from ice or carbon. It comes from machines. This pushed scientists to stop guessing, because 3I Atlas was no longer behaving like a comet. It was behaving like something alive, or something designed to act like it was. And James Webb saw all of it, long before we were ever told. Signals that shouldn't exist. The heat was strange enough, but it was the signals that changed everything. 3I Atlas was already pulsing on schedule.
It had a very funny shape. It's shaped like a cigar. It's maybe 5 or 10 times as long as it is across.
Every 4 hours, James Webb recorded an internal glow, but then another pattern emerged. A team at the Allen Telescope Array in California pointed their receivers at the object. For days they heard nothing unusual, just the regular silence of deep space. Then, without warning, a narrowband radio pulse appeared. The timing was identical to the thermal pulses recorded by Webb. This was not a random emission. It was locked in sync with the internal heat of the object, and that raised an immediate alarm. The signal did not match anything naturally known in space. At first, researchers thought it might be an error, maybe local interference, maybe a satellite reflection. But other observatories began pointing their instruments at the same coordinates. From South Africa to Australia, the same signal was heard. Fourier analysis was run to examine the waveform. It revealed a stable carrier wave with subtle modulations, the kind used in artificial transmissions. NASA still gave no official comment. Internally, however, requests were made to send a test message to provoke a response. A short sequence was transmitted using the same frequency band, and 72 hours later the pulse changed. A new signal arrived, and it came at the exact predicted window, but with a new modulation embedded inside. Some scientists argued it was a coincidence, that the signal had simply glitched. But the reply wasn't random. It mirrored the structure of the outgoing message in rhythm. This was the moment many experts privately admitted what they had feared. The object was beginning to respond. The radio pulses were also not exactly identical each time. Small variations appeared, shifts in tone, duration, and amplitude. These shifts matched changes in solar wind pressure. When background cosmic radiation increased, the pulse adjusted. When Earth rotated farther from optimal alignment, the signal grew stronger. This meant the signal was adaptive. No natural body does this. Stars do not adjust to observation. Comets do not optimize their signal strength. But 3I Atlas was doing exactly that. What made it worse was that the signal was not broadcasting equally in all directions. The strongest signal strength was focused toward Earth. The European Southern Observatory confirmed this using sideband receivers. The signal weakened rapidly just a few degrees off angle. This was not a wide broadcast. It was a laser, and we were the target. One team tried overlapping the signal with known astronomical events. Supernova, gamma bursts. They tested it against the WOW signal's waveform. The match was not perfect, but it was close enough to trigger panic. If this object had stored the WOW signal, or worse, if it had sent it, then it meant 3I Atlas had been here before, or had been watching us longer than we realized. The object steers itself. The signals were alarming. The pulses were precise. But the moment 3I Atlas changed course,
this was a really dramatic difference from what had been seen previously.
Everything shifted from strange to impossible. Objects that enter our solar system on hyperbolic paths do not turn. 3I Atlas broke it. The confirmation came on a quiet August night. Webb recorded a sudden spike in brightness. It rose by roughly 40% in under 1 hour. No comet flares like that. Even large eruptions of ice or dust rise unevenly and fall quickly. But this flare was controlled, smooth, even, clean. It looked more like an ignition than an eruption. Within minutes, orbital analysts noticed something worse. The object's trajectory had shifted. It was a measurable directional correction. The change moved 3I Atlas closer to the ecliptic plane, closer to the paths of the inner planets, a path that happens to align more directly with Earth. When the models updated, the shift was undeniable. The first explanation offered was outgassing, which is a common cause of small nudges in comet paths, but the math failed instantly. The required thrust was far too strong. The European Space Agency ran independent simulations. This forced analysts to consider two unsettling options. Either the object had an internal propulsion system, or it had a method of altering momentum without thrust. Both ideas are beyond our current engineering capability. Both ideas suggest intelligent construction. NASA's delay in updating orbital data created confusion among amateur astronomers who noticed the shift before the official charts changed. This made the silence from official channels feel deliberate. Webb continued tracking the object during the shift. The heat source at the core remained stable. The pulses continued at their precise 4-hour rhythm. But now the object had an added pattern, a slight rotational change that seemed too orderly to be accidental. Light from the flare had revealed something unusual on the surface, a faint grid-like reflection. Not a smooth rock, not a porous comet shell. Something with structure, something built. And that reflection seemed to align with the direction of the trajectory change, almost like a guidance system orienting itself. At the same time, ground telescopes detected small but consistent fluctuations in mass distribution. These variations suggested the object was shifting weight internally, as if using ballast. That kind of maneuvering exists on spacecraft that stabilize orientation, but there is no known natural object capable of redistributing mass from within. The shift was not large, but in space, tiny corrections make enormous differences, and the new trajectory pointed with steady confidence toward an area of the solar system dense with instruments and communication arrays. Data from the Deep Space Network showed another subtle pattern. The course change occurred at a point where communication clarity was strongest. It adjusted at the optimal alignment for two-way signal exchange. It mirrored the behavior of a probe trying to maintain contact. Experts at the Jet Propulsion Laboratory ran models comparing the object's correction to the behavior of known spacecraft. The similarity was uncomfortable. The path matched the kind of arc used by probes preparing for observation or approach. The trajectory was undeniably intentional. By the end of the analysis window, the scientific community privately accepted a truth that no one wanted to say publicly. 3I Atlas was not following physics, and James Webb recorded the shift in real time long before the public was allowed to see it. The materials that shouldn't be there. What James Webb saw on the surface of 3I Atlas was already unusual, but it was what came from inside the object that forced scientists to reconsider everything they thought they understood about materials in space. The first clues came from Webb's spectrograph. The system was designed to read the chemical makeup of objects by breaking down the light they reflect and absorb. Underneath the standard cometary signature, there were layers that did not belong. The absorption lines in the spectrum showed compounds never recorded in any natural object. Some of them were weakly reactive metals, others were stronger and sharper, and they caught immediate attention, because those lines matched certain rare Earth elements used in advanced technology on Earth. One group of compounds mirrored the properties of yttrium and neodymium. These are not random cosmic minerals. They are refined components in laser systems, superconductors, and stealth coatings. But those materials are not supposed to appear inside deep space objects. They do not form without industrial processing. Still, scientists held off on jumping to conclusions. There have been cases where spectral lines were misinterpreted. But then came the second set of anomalies. Some parts of the object's reflection spectrum bent infrared light in patterns inconsistent with any known natural surface.
But it means that 3I Atlas is scattering light in such a way that has never been seen before for any other comet or asteroid in our solar system.
Instead of scattering light the way rock or ice would, they seemed to redirect it, absorb it, and then emit it back in controlled pulses. These are the characteristics of metamaterials. Metamaterials are engineered structures built at the microscopic level to manipulate light, heat, and radio waves in very specific ways. On Earth, they are used in experimental cloaking systems and high-performance optics. James Webb's readings indicated these materials were not just present, They were precisely layered. Sections of the outer shell showed alternating bands of high reflective and low reflective compounds, mimicking designs used in light-trapping technologies. Another signature suggested a different kind of substance entirely, something that responded to solar radiation by changing shape. These were not rigid materials, they were polymers, long chains of molecules that can flex, bend, or shift based on environmental cues. And these particular polymers behaved like programmable matter. They altered their thermal response in direct proportion to solar exposure. That meant they were not passive, they were reactive, as if they had been designed to adjust their behavior in real time based on sunlight intensity. Webb's data scientists flagged this behavior as non-inertial surface variability, but the team at Johns Hopkins gave it a different name: hybrid architecture. The structure of 3I Atlas did not match the profile of any known comet or asteroid. It was not a rock. It was not just frozen gas. It was a layered shell of responsive material built to withstand deep space radiation, reflect selected wavelengths, and regulate its own internal energy output. The idea of a spacecraft came up early, but the object showed no visible engines, antennas, or solar panels. And now there were materials that should not be present on any natural body. Another theory proposed it was not a ship, but a probe. A more radical idea was floated inside a closed-room briefing: a seed, not a payload of machinery, but a capsule, built with the intention to survive for millennia, possibly longer. All three theories, ship, probe, seed, raised the same conclusion. Whatever this object was, it was made, and it was very active. This meant the presence of the rare materials was not an accident.
Using all the assets we have on Earth and in space to get as much data as possible about this mysterious object.
They were part of its design. Every layer, every polymer strand, every reflective panel, they were all put there for a purpose. That leads to an even more chilling idea. If these materials could not be made on Earth, then whoever built this object was operating with access to environments and methods far beyond our current capabilities. There is no natural reason for metamaterials to exist inside a comet. There is no geological event that can create programmable polymers. There is no cosmic accident that produces heat-stable reflective grids lined with rare Earth coatings. There is no ice that responds to sunlight with rhythmic pulses. Despite the flare, despite the course change, despite the exposure to radiation, solar wind, and telescope observation, the object had not degraded. It maintained temperature control. It continued to emit structured signals. It reacted to every scan, every transmission, every attempt to get closer. James Webb's final report on this segment classified the surface readings as consistent with functional multi-domain material engineering. That phrase is technical. What it really means is this: the object was built to survive, it was built to think, and it was built to be found. And that means someone might still be watching. The face, the vault, and the final signal. After weeks of silence from officials after the pulses, the signals, the course correction, and the impossible materials, James Webb recorded something no one expected: an internal structure. Their imaging feed caught a sudden shift in surface geometry. A rectangular section of 3I Atlas retracted. It pulled inward smoothly, like a panel. The edges were straight, the corners were precise, and movement was even. Nothing natural behaves like that. Organic patterns like this exist in nature. You see them in nautilus shells, sunflower heads, hurricanes. But they are not found in rock, and certainly not found in objects moving at thousands of kilometers per hour through deep space. And it stayed pointed directly at Earth, almost like it knew it was being observed. It reacted to our instruments. It reacted to our test pulse. It reacted to our analysis. And then, it adjusted its own behavior to control what we could detect. Mass readings from Webb and several ground telescopes showed something that could not be explained. The internal volume of the object was larger than the outer shell could possibly hold. Inside the cavity, Webb detected a zone that absorbed all light, a region not just sealed off, but locked. It was clear that it was not meant to open with force or meant to remain dormant, and only meant to respond only when understood. The geometry of the entrance did not match standard Euclidean planes. It curved in ways that defied mapping. Multiple teams tried to decode it, but none of them succeeded. The working theory became this: it is not meant to be decoded, it is meant to be recognized, and maybe only by those it was designed for. 3. I-Atlas is not just strange or extremely unnatural, it is a vault, a sealed chamber of memory, information, and presence. It has given us just enough to know it is real. If James Webb found all of this in only a few weeks, what else has it seen that we have not been told?